Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, we are going to talk about exponents. So I know that most of you in late middle school, early high school, you dealt a lot with exponents. So we are going to just review them quickly, make like a short summary of it, okay? So we start with the laws of exponents. Oops. Oh my God, I dropped my external hard drive. Should be more careful with that. Saving these videos on it, but okay, it doesn't matter. Sorry. So, laws of exponents. And then maybe we'll have one for logarithms. The laws of exponents. We say that if we have something like x to the a, what does that mean? The x here is the base and a is the exponent, and that's a quick way or an abbreviated way of saying x times x times x a times whatever a is. So you know that x squared is x times x. A Google is 1 with 100 zeros, so we say 10 to the 100. We don't keep writing. And even if I write them and I write them correctly and I show them to you, you have to count the zeros to understand what I'm writing. So it doesn't make sense, right? So it's easier to express numbers or variables with exponents. Okay, so keep in mind, the a on the top is the number of times I multiply the base by itself. So for example, if I say 3 times 3 times 3 times 3, 4 times, I say, no, that's too much. I can simply write it like that and I'm done. Okay? Okay. So now that's not a law of exponents, but the first law of exponents that I want to talk about is that if I have x to the a and I multiply it by another power of x, the bases have to be the same. If they aren't, you cannot use these laws, okay? X to the b, yes, you know, I heard you. It's x to the a plus b. So now it's as if the multiplication in algebra now becomes an addition in exponents. It simplifies the multiplication into addition. That's easy. Nice. An example, if I have to say, here I had 2 times 2 times 2, and I multiplied that by 2 times 2. So, of course, this is the same as saying I multiply 2 by itself 5 times. 2 to the third, 2 3 times 2 to the second 2 times is 2 to the fifth. I multiplied it 3 times, and then I multiplied it another 2 times. So altogether, I multiplied it 5 times. So you see, I don't say 2 times 3 is 6 and 2 to the 6. No, 2 times 3 is 8, and 2 squared is 4. And when I multiply 8 by 4, I get 32, which is 2 times 2, 4, times 2, 8, times 2, 16, and times 2, 32. Okay? So it simplifies. When you have a multiplication of the same base, you simply add the exponents. Of course, you would answer before I ask. I know. If I have x to the a and I divide it by x to the b, yeah, absolutely. Since the multiplication became addition, then the division would become, yeah, I heard that. I'm going to write it without saying it. So when I have something like 8 to the fifth divided by 8 cubed, I get 8. Oh, I'm sorry, I didn't write that. Let's see. to the 5 minus 3 equals 8 squared, or 64. Okay. Alrighty, so these are the first two. Now let's go a little higher. What if I have x to the a and the whole thing is raised to the b? What do you mean? I mean, suppose I have 3 squared and then I raise the whole thing to the power of 3. If I want to break it down, I can write it as 3 squared times 3 squared times 3 squared, right? Because I did it 3 times. The 3 squared, which is inside, I multiplied it by itself 3 times. But the multiplication mean addition, right? So this is the same as 3 to the 2 plus 2 plus 2. We usually don't like to add something to itself n times. No, we write it as 3 times to the power of 2 times 3. 2 plus 2 plus 2 is 6. Why do we keep adding 2 to itself 3 times? We say 2 times 3, or 3 to the 6. So here I multiply 2 times 3 and I got 6. So x to the a, the whole thing to the b, equals x to the a times b. So here the exponent becomes multiplication, which is easier. Notice, please remember, if you see something, you won't see it in this course, but later on, if you see something written like that, x to the a to the b, that doesn't equal x to the a raised to the power of b. Here we raise a to the b first and then take x. So don't confuse yourself. If you always have to use parentheses, because if you don't, people may think you wanted to say 2 to the third power is 8, and this would be 3 to the 8, not 3 to the 6. So they raise the power, a power of a power, like 3, a to the b, and then you take x to that power. No, that's not what we mean here. Okay, let's move to a fourth one. What is the bth root of x to the a? What's bth root? Yeah, a square root, or a cube root, or a 10th root. It doesn't matter, any b. The root is the opposite of the exponent. So if I say x squared, its opposite is the square root of x. If I say x cubed, its opposite is the cube root of x. So the bth root of a is x to the a over b. So now the root became division in the power. Okay? So for example, if I say, what is the cube root of x to the 12? It's x to the 12 over 3 equals x to the 4th. Okay? So now these are the main 4 rules. There are a few other rules, very simple ones. Like, for example, I can say any base other than 0. So any base other than 0 raised to the power of 0 equals 1. Say, what is even the power of 0? I say, well, I can use this and say, what is x to the a divided by x to the a? Well, if you divide the number by itself, other than 0, you get 1. So this equals 1, right? 2 cubed divided by 2 cubed, 5 to the 6 divided by 5 to the 6. Any number divided by itself equals 1. But according to this rule, this is x to the a minus a, because I divided x to the a by x to the a, not to the b. But a minus a is 0, so this is x to the 0. Based on that, there is another rule you can get. One over x to the negative a equals x to the a. What is a negative exponent? Yeah, this rule says if you have a negative exponent, either in the numerator or the denominator, we don't like that. So you change its position. If it's in the denominator, you bring it back to the numerator. If it's in the numerator, you bring it back to the denominator by multiplying the exponent by -1. So you make it positive instead of negative. Well, yeah, you know that if I write that, like this is like divided by 1, right? And use the cross product or the butterfly method, this says that x to the a times x to the negative a equals, well, in multiplying, I add the exponents. So it's x to the a minus a equals x to the 0. And from here, x to the 0 equals 1. So really, this is the same as 1 over x to the a. Okay? So the rules are very simple. Multiplication became addition. Division became subtraction. Power became multiplication. Root became division. And then any number raised to the power of 0 is 1. And any negative exponent, you can switch its position from numerator to denominator or vice versa and get away with the negative sign. Of course, these problems are trivial, right? When I say 2 cubed times 2 squared, 3 plus 2 is 5, so it's 2 to the 5th. But sometimes you get that as an equation, for example, and not with the same base. You say, what? If it's not the same base, I cannot do anything, right? Yes and no. Okay, let me give you an example. Let's say 4 squared times 2 to the x minus 1. Can I simplify that? Yes. Yes, you can. How? You look at the bases. If one is like a product or a power of the other, then you have a solution. I know that 4 is 2 times 2. So I'm going to rewrite that. Instead of writing it 4, I should have used let's make that a 3, because everything here would be 2's and they confuse. I'm going to say 4 cubed times 2 to the x minus 1 equals something. I'm solving an equation, okay? We learn about equation. In fact, I think I did already a video on equations after you learn the logarithms, how to solve these equations, and it's not hard. Because the 4 is a power of 2, so if this was a 4 or an 8 or a 16 or a 32 or then you can apply this very easily. You say, okay, the 4, I want to write it in terms of 2. Okay, so the 4 is 2 squared. Notice the 4 was raised to the 3rd power. So the 2 squared, and that's why I use the parentheses. Remember, I just told you, don't write it 2 to the 2 to the 3 because it would be incorrect. No, the 4, which is 2 squared, all of it is raised to the power of 3. Not just the 2, it's 2 squared times 2 to the x minus 1. If I go back to the 3rd rule, it told me x to the a to the b is x to the a times b. So this can be written as 2 to the 2 times 3 times 2 to the x minus 1. 2 times 3 is 6. So this is 2 to the 6 times 2 to the x minus 1. The first rule said x to the a times x to the b is x to the a plus b. Same base, multiplied, so add the exponents. Equals 2 to the 6 plus x minus 1 equals 2 to the 5 plus x. Or x plus 5, it doesn't matter which one you write it first. Notice that, or you can break it back. You can go from here to here. Since I have number and variable in the denominator, so I could have said this is 2 to the 5th times 2 to the x. I break it down. I do backwards. See here, when I multiplied, I add. Here, I have addition, so I break it into multiplication. 2 to the 5th is 32, so I still can write it as 32 times 2 to the x if you want the power by itself. But you don't need it. This is good enough. So you see, I had a 4 and a 2. It's not the same base, but I can make them the same base. Okay? In fact, someone can say, I hope this doesn't confuse you, but someone may say, you know, I don't want to, not to play a trick on my teacher, but make my teacher's life harder in grading. What do you mean? Well, isn't the 2 equal the square root of 4? Yes, it is. So the square root of 4, I want to stop here for a second to tell you. Please remember, if you have a square root for some reason, we don't write the 2 here. Square root meaning a second root. So when we say the 5th root, we write it like that. When we say cube root, we write it like that. But when you say square root, we never write the 2. But you have to understand there is a 2. So if I want to write that, I write it as 4, and 4, it's this, there is a 2 and there is a 1. Any number is raised to the first power. Why did I say that? Because I want you to look at this. The second root of x to the first power. So it's x to the 1 over 2. The square root can be written as 4 to the 1/2 to the x minus 1. And like I did here, I'm going to say this is 4 cubed, which is 64, by the way, times 4 times 1/2 times x minus 1. I'm just making it more complicated. Looks more complicated, but in reality, it's not. And now this is a multiplication, so I can add them. I can say 4 to the power of 3 plus 1/2 x or x over 2 minus 1/2. So it's 4 to the 2.5 plus x over 2. And even though it looks horrible, it's correct. It's 4 to the 2.5 plus x over 2. If you don't believe me, go back and write 4 as 2 squared. 2 to the 2 to this power. And because the exponent becomes a multiplication, it would be 2 to the 2 times that. 2 times 2.5 is 5, and 2 times x over 2 is x. So really, as long as these are powers of one another, you can apply the laws easily. And if they aren't, there is another way that we are going to talk about later. But these are the main rules of exponents that you can use them to simplify and add and subtract many things. Okay? Again, a very short. Well, it's not a very short, but I think it's not long uh, as I thought it would be. And I think we did these 6 laws, and variation of that. We said always that you cannot apply these laws unless you have the same base. But sometimes we can trick you into giving you what appears to be different bases. Yeah, of course, they are different bases, but one of them can be written as a power of the other, either 2 square or 4 to the 1/2. Okay. Hope this wasn't bad and you learned something new. Um, and again, if you have any comments, please leave me a note in the comment section and I will get back to you as soon as I can. Otherwise, hope to see you soon. Bye.